Let's take a look at page 190 in our journal, and let's just think about how the properties give us flexibility. So the associative and the commutative properties help us rearrange terms and expressions to suit our needs, and it helps. So anyway, you can see here if you were able to reorder your addends, the addends are the parts that you're adding together. So if you could reorder them, you could get three different equivalent expressions here. So here if you were to, and remember this is just adding. If all of these terms are just being added together, you can rearrange them, reorder them. So 1 plus x plus 3 would give you the same amount as x plus 1 plus 3 would give you the same amount as x plus 4, because 3 and 1 are 4. Here we just reordered them. So you'd get the same answer in all of those. They're all equivalent or equal. Here's an example of regrouping. Let's say you wanted to add 5 and x, and then add that answer to 4. You'd get the same result that's equivalent as 4 and 5 added to x, or just 9 plus x. They're all the same. On page 190, we are going to model each expression with algebra tiles and then rearrange our thinking. We're not going to actually use physical tiles on the paper here, but you could, to model an equivalent expression with fewer terms. So let's think about that. We want to model an expression, an equivalent expression. So we don't want to change the value or the end result, but we want to use fewer terms. Remember, the terms are all the different parts working together when you add and subtract. So we're just focusing on addition here with these properties. So we're going to write a new expression and make drawings. So let's say we wanted to kind of filter all this down and make it shorter, not as many terms. Right now we have 1, 2, 3, 4 terms. So here's a model of the original expression. So this is the original expression. Let's think about this. So 6 would be each of those tiles, right? Number tiles. So we could do a little square 6 times 6 of these small squares, or you could do dots, I guess, plus 2 of the rectangular tiles, which are 10 each, right? Plus 1 more small tile, plus another long 10 tile, rectangular tile. Now, how could we regroup these? Well, I see that there are 7 small ones total and 3 larger ones. So instead of adding the small ones separate and the larger ones separately, I'm just going to say, well, 7 singles plus 3 of the X tile, rectangular long tiles, would give us the same amount. So we turn this into this. So these are both equivalent. Here's a model of the rearranged order. So this time all of these small single tiles plus that 1 are going to be added to those 3 rectangular tiles. So this is easier to look at than this. All right, let's look at number 2. Here we have three of those long X's, so maybe it would help us to just go ahead and draw it first. I have 3 of those, plus a single one, plus another single one, plus 2 more of the X's. So I'm going to rearrange these. This time I'll put the long ones first. I had 3 plus 2 more, and then I can just put those 2 together. And that's going to be like saying 5 of these plus 2 of those. So 5 of X, multiplying means of, 5 of it, plus 2 small ones, right? 2 separate ones. 2 units. Down here below, I've got, I have an X plus 2 plus another x. You can see how crazy this would get, right? Plus 4, this time maybe I could put them all, block them, plus an x. Is that right? Here's a model of a rearranged expression. So this time maybe I could just draw it better and then I'll write it last if I didn't do that earlier. So I'm going to start with these 3 tens blocks or rectangular tiles. And then we had 2 and then 4 more. So it's easy to see that I have 3 x's plus 6 single units.